In this video, we're going to be talking about Objective 1.6 called Photoelectron Spectroscopy / PES. So the learning objective states explain the relationship between the photoelectron spectrum of an atom or ion and its electron configuration for that species, and the interactions between the electron and the nucleus. So photoelectron spectroscopy, or also known as PES, is an experimental technique used to measure the energies of the electrons in a given shell, and that shell is talking about which energy level of which it's in. So a PES can be used to determine an electron configuration. It's actually relatively easy to do. You just have to make sure that you are reading it correctly. So the peaks in a PES spectrum correspond to the electrons in different subshells of the atoms. Remember, subshells are talking about the S, P, D, and F. The position of each peak in the PES spectrum is related to the energy required to remove an electron from the corresponding subshell. So when we talk about that energy, we're talking about ionization energy. Okay, that's the energy needed to remove an electron. Please note, when we remove electrons from energy levels, we always work our way outside in. Okay, you wouldn't just start with the 1s and remove electrons. You would start with your valence electrons and you work your way towards the core electrons. The height of each peak is ideally proportional to the number of electrons in the subshell. Okay, so when we talk about the y-axis, we're talking about number of electrons, and it's going based off height. When we talk about the x-axis, we're talking about ionization energy. So if we have lower binding energies, these are going to be our valence electrons because they don't require as much energy. But when we talk about higher binding energies, we're talking about the inner shell or core electrons, okay? So the larger that value is, that means we're probably very close to the nucleus. This is very important. This is the trick. You always read left to right on the graph because that's going to correspond to an electron configuration, starting with 1s, working your way, so on. So let's look at this example right here. Determine the identity of the element from the PES graph below. So you can see this right here is going to be essentially number of electrons in that subshell. Here I have ionization energy, so how much energy is needed to remove those electrons. You can see I have 3 peaks right here, and so you can see this is a little bit different than most graphs. Most graphs you start at 0 right here, but in this case you actually are starting at the largest value and going to the right. And so again, following that little trick of reading left to right, you can see that we're at 90,000 and the thousands over here. So this tells me that this first peak, and looking at its height, this must be the 1s, and there's 2 electrons. I know there's 2 electrons because I see other peaks right here. So I'm making the assumption that this is a filled subshell. Next, these 2 little lines right here are just indicating that there is just a big jump, or I guess jump down from energy level. So this is talking that this is referencing towards a different energy level. So this next one, I mean, think about it. We're going in between, what, 85,000, and we're jumping to almost like 4,300. So here, that's a large jump, okay? So this tells me that this has to be the 2s2. This last peak is still relatively close to our 2s, so I'm going to make the assumption that this is the 2p. Now, knowing that this is the height for 2 electrons, I'm going to assume that the top of this peak is going to be 6, assuming that this is 2 electrons, 4 electrons, and 6, going based off that x-axis. So here, this tells me this peak should be the 2p2. Hold on, sorry, 2p6, sorry. So here, my electron configuration, putting it all together, is 1s2, 2s2, 2p6. And looking at our periodic table, that element, the identity of basically what element has this PES graph, this would be neon, okay? Don't worry about ions. Basically, your PES graph is going to correspond to a neutral element. Don't worry about ions, okay? All right, so why don't you pause the video and try this out yourself. And then once you identify the element and its electron configuration, press play and I'll go over the answer. All right, so since this is relatively straightforward, I'm just going to work this one out with you. So here, reading left to right, I can see that this is the 1s2. I then move on and I can tell that this is the 2s2 and 2p6. Reading left to right, essentially on a PES graph is the same as going through a periodic table. The next one, these next two peaks basically look very similar to the 2s2 and 2p6, so I'm going to assume that's 3s2 and 3p6. Lastly, I see one little peak by itself and it looks like the same height as the 1s, the 2s, and the 3s. So I'm going to assume that this is the 4s2. So putting this all together, I get that my electron configuration, or this PES graph, is this. And this is going to correspond to the element calcium. Okay. And again, this is just going to be neutral elements, just corresponding electron configuration to its position on the periodic table.